Alrighty, so we were doing some log stuff. We've been doing that for a couple of weeks. We will just pick it up right there. The goal here for all of these is to solve for x. Notice how the x is in the exponent. So that means we have to do something with that exponent. Let's look at D. 10 to the x plus 1 minus 10 to the x equals 9,000. There's only one thing we can do here. What would that be? And the answer is, no, you can't use log right now. Log you would use if you have one item here and one item here. And you have some exponent things going on. But if you have like something plus something, like we do, or something minus something, you can't do log just yet. This one, I don't think you even have to do logs. 10 to the x plus 1. We can break this apart. It becomes 10 to the x times what? It's
10.
this, yeah, 10 to the 1. And then minus 10 to the x equals 9,000. Now from the left here, can we pull something out? Do they have anything in common, the two terms on the left?
10.
10 to the x. What are you left with if you pull out 10 to the x? It's the same idea as this. A times 10 to the 1 minus a, right? If you pull out an a, you're left with 10 to the 1 minus 1, like that. So what are we left with in this bracket? It's the same
1
idea.
times 10 to the power 1 minus 1.
Yeah, like that. What's 10 to the 1 minus 1?
It's 9.
It's 9. So you have 10 to the power of x times 9 equals 9,000. And you can divide both sides by 9 here. 10 to the x is 1,000. Now at this step, this is a step where you want to use logs. You need to get to this step before you can use logs. But here for this one, you don't have to because we can kind of do this in our heads. 1,000 is 10 power 3, right? Like this.
Mm-hmm.
And then on the left side, you have 10 power x. So what's the final answer? What's x equals to?
3.
3, and you're done. Okay, that's it. That is it. So here, this, you don't have to use a log. But if you can't write one side of the equation in terms of the other, then you would want to use logs. Or you could use logs either way, but this way you don't need a calculator, basically. The next question is exactly the same. What's the first step? You want to
Turn
break
that
this.
into 3 to the power of x times 3 to the power of 2.
Yeah. And then look at how easy this is. Now you want to pull out 3 to the x. What are you left with?
3 squared plus 1.
Yeah, 3 squared plus 1. That's a 10. So you have 3 squared times 10 equals 30. You have 3 to the x equals 3. So what's x equals to?
1.
1, and you're done. F is the same. We don't have to bother with that. Now here is where you want to use logs on the first step, because you can't really write 4 in terms of 5 or vice versa. So here is where you want to use logs in the very first step. And there's no plus minus thing going on. There's one term on the left, one term on the right. This is the one where you want to use logs like this. The whole point of using logs is to bring the exponent down to the same level. So you have 2x times log 4 equals 2x minus 1 times log 5. How do you solve this for x? This is a linear equation. It's just multiplying by log terms, but it's a linear equation. You want to open the bracket on the right. Look at this. 2x times log to the 4. If you open the one on the right, what do you get? What's 2x times log 5? It's just 2x times log 5. What's the second term?
Minus log 5.
Minus log 5. So you just want to open the bracket there. Now again, this is still a linear equation. You want to group up the like terms. You see how there's an x on this term and x on this term? You want to make sure that they're on the same side so we can pull out that x. So subtract this term, 2x times log 5 from both sides. Becomes like this. Now in the next step, you want to pull out that x. What are you left with if you pull out that x? There's an x here and an x here.
2 times log 4 minus 2
Right, 2 times
times log 5.
log 5, and then finally, the last step, you want to divide both sides by this bracket. So therefore, x becomes negative log 5 over 2 times log 4 minus 2 log 5. And you are done, okay? So if you can't write the base in terms of the other base, that's when you want to use logs, but make sure there's one term on each side of the equation. Otherwise, you probably have to clean things up a bit. For D, now our x is missing. There's two ways you can attack this. I'll show you both ways. One way is going from an exponential to a logarithm and vice versa. The way it works is like this. You have log b of a equals c. This right now is in logarithmic form. You can turn this into an exponential form by doing b to the power of c equals a. In this question, 2 is your b, this is your a, and this is your c. If I want to rewrite that in exponential form, in this form, what does it become? Right now we're in this form. We want to go to this form. B, right? B. So 2 to the power of what?
X.
X equals 53.2. Now here is where you want to use logs because you can't write 53 in terms of 2. It's not a 64 or 32. So X becomes log of 53.2 divided by log of 2, okay? And that's it. You just plug that in a calculator. The other method is to use change of base. Which says if you have something in this form, you have log b of a in this form, you can rewrite this in terms of base 10s. Right now the base is 2, but you can rewrite this in terms of base 10 and it becomes log a over log b. So for this question, it automatically becomes log 53.2 divided by log 2, which is the same thing as you have here. And that'll be the final answer. You just plug that in a calculator. Does that make sense? This is the crux of this entire chapter. To be able to go from one form to the other when needed. Not always you're going to be able to write one thing in terms of the other. So you have to be able to go back and forth. is our next question. A lot of words, but it's about light intensity is reduced by 5% if the plastic is a millimeter thick. Each additional millimeter will reduce it by another 5%. Let's look at this example. Let's say you have 100 grams of something, okay? It reduces by 50% per day. So after day 1, how much mass is going to be left?
50.
50. What about after day 2?
25.
25. And day 3 will be 12.5. Day 4 will be 6.25. Yada yada. Is this linear or is this exponential? If it was linear, minus 50, here it should have been 0, right? Here it should have been minus 50. So is this linear?
No.
No, it's not. It's exponential. If you graph this out, on day 0 you have 100, so up here, and then day 1 you have like a 50, so half of that, and day 2 you have 25, day 4 like this. It'll look like this. So that is an exponential function. It's going down. So it's the same kind of idea here. Per day, it's losing 5% of its intensity. Is this linear or is this exponential? So let's say day 1 you had 100, loses 5%, becomes 95. This is the most important part. Day 2, is it gonna become 90 or is it gonna become something else? It's losing 5% each day.
It's gonna become something else.
Yeah, so now the question is, what is it going to become? And this is the answer. It's gonna be 95, the original, times 1 minus the rate at which it's going down by. So here, this will be 95 times 1 minus 5%. So 1 minus 0.05, which is 90.25. And here's why. It's decreasing 5% relative to what it was the day before. Okay, or the millimeter before, not relative to the original. 90 would mean that this day 2 value is dependent on the original. It is not. It's dependent on the previous day's value. So here, this is an exponential. I can give you the formula for this, but you can come up with it by yourself by using that kind of logic. We can say that, what should we use? I don't even know. Let's use NT. NT is the final intensity. That is equals to N0, which is the initial intensity, 100%. Times 1 minus the rate, and minus because the intensity is being reduced, to the power of T, where T is the millimeter or the thickness or whatever. So this is the equation. What's the initial intensity? What's N0? What's the intensity on day 0 or when it's 0 millimeter thick?
It's 100.
It's 100, right? So that's a 1 times 1 minus the rate, which is 0.05. So 1 minus 0.05 is 0.95. And 1 minus 0.95 is 0.95. So this is the equation. This is the answer to part A. Part B, how thick is a piece of plastic that reduces its intensity to 60%? So this is our equation. What have they given us? What is 60 or 0.6? It's the final intensity, okay?
Mm-hmm.
It's the final intensity. So this is 0.6. Now, how do we solve this equation for T?
You do log.
Yeah, you do log. So t will be log of 0.6 divided by log of 0.95. So log of 0.6 divided by log of 0.95, that is 10 millimeters. And that's the answer to this question. That makes sense?
Mm-hmm.
Do you understand why this is exponential and not linear?
Uh-huh.
This one is slightly more difficult. Can we use logs on this very step right now?
No.
No, you can't. You want to have one thing on the left and one thing on the right. So what do you do in this case? Last time we had it in this form where we could break it down into this, right? And we could take out the 3 to the x. That made things easier. But here we can't really break this down into anything. I guess you could write this as 3x squared. But even if you were to do that, and you were to take out a 3 to the x, you'll see that you still have a 3 to the x inside. So that's not the approach here. You can't break it down. So for this one, you have to identify it. You have to identify something. Can I rewrite 3 to the 2x as 3 to the x squared?
Mm-hmm.
Minus 5 times 3 to the x equals negative 6. Now for a question like this, we would pull out the 3 to the x, and that'll give us a number in the middle. Like if you were to do it here, you'll get 3 squared plus 1 equals 30, and then x will be 1. But this is different. You could pull out the 3 to the x, but you're not going to be left with a number inside. So that approach is not going to work for this question. What if I let, and this is the trick, once you know it, you can do all of these questions. What if I let 3 to the x be a? Now, what does this equation turn into in terms of a?
A squared minus 5 times A.
Yes, a squared times 5a equals negative 6. You can bring that negative 6 onto this. So now what does our thing have? What kind of function is this?
Quadratic.
Quadratic. So this is a trinomial quadratic. How do we factor this?
You use man.
Use man. So what are the numbers? It multiplies to positive 6, adds to negative 5. What are the two numbers?
-6 and -1.
Okay, negative 6 and negative 1. Does that work? That's going to add up to negative 7, so that's not the combo. Only one other thing multiplies to 6.
-3 and -2.
Negative 3 and negative 2 is right. So a minus 3, a minus 2 equals 0. So that means a is 3, and that means a is 2, right? Like that. But the answer is not
Mm-hmm.
asking us to solve for a. The answer is asking us to solve for x. Now we're going to go back up here. 3 to the x is equals to 3, and 3 to the x is equals to 2. What's x equals to here if 3x is 3?
1.
1. The other one is slightly more difficult. You have to use logs. It's going to be log 2 divided by log 3. And there you go. Those are your two answers to this question. Okay?
Mm-hmm.
This is the same thing here. You actually, yeah, if you see an x squared, it's more often than not, it's going to be a quadratic thing. Here, let me show you
Mm-hmm.
here. I don't know how difficult this is, but it doesn't look too bad. 3x squared plus 20. What's 1 over 27 in terms of 3?
3 to the power of negative 3.
Yeah, so it becomes 3 to the power of negative 9x when you multiply it with that. Can we cancel this 3 with this? The answer is yes. If there was a plus 2 or something, then you couldn't do that. But as long as there's one base to the power, one base to the power, you can cancel them out. Then you get x squared plus 20 equals negative 9x. How do you solve this?
Can you move the minus 9x to the other side?
Yeah. Becomes a plus 9. Now what?
You subtract 20.
No. It's a quadratic trinomial.
You do man.
You do man, right? So I'll give it to you. It's 4 and 5. Positive 4, positive 5. We'll do it. So x is negative 4 and negative 5, and we're done because we're being asked to solve for x. So here we don't have to use logs, right? Because we could cancel out the bases. If you can't do this, then you would have to use logs. The rest of them is the same stuff. You like earthquakes? The next one's an earthquake question. I don't know why anyone would like earthquakes, but this is called a seismograph. You seen something like this in TV or any news or something?
Mm-hmm.
There's a needle that's held stationary in point, and if the ground shakes, it's gonna give us a graph, and that'll tell us how big the earthquake is. And the way earthquake is measured, the units is called the Richter scale. It's from 0 to 10. We've never had a 10, but we've had something like 9.6 or something. It's huge. So the equation for this is given up there somewhere. The Richter scale R is equals to log of A, which is the amplitude, T, that's a period of the waves, plus B. B is like a constant. So what have they given us here, and what are they asking us to find? So they're giving us the Richter scale, 5.5. So R is 5.5. Log is log. Well, that doesn't change. What else have they given us? They've given us a period is 1.8. So our T value is 1.8. and B is 3.2. They're asking us to find or solve for A. What would we do with the first step here to solve for A?
You subtract 3.2.
You subtract 3.2. Okay, that'll give you 2.3 equals log of A over 1.8. What's next?
Do you open the bracket?
Okay, if you open the bracket, what would it become? Does it become log A over log 1.8? Or does it become a log A minus log of 1.8?
The second one?
The second one. Yeah, you could open the bracket. That's one way of doing it. So if you do it this way, this is what you get. You want to add log of 1.8 on both sides. This becomes log of A. This is simply a constant. 2.3 plus log of 1.8 is 2.56 or 2.6. Now how do you solve for A? You need to turn it into an exponential.
You do the inverse?
You do the inverse. That is correct. Here's what you do. You want to go from, it's just this idea. It'll become b to the power c equals a. Okay? What's the base here? It's invisible. If it's invisible, what's the base?
10.
10. So 10 to the power, so this is the answer. 10 to the power 2.6 is a. That's whatever that is. I think 200, 300. Maybe it's more than that. Let's see. 10 to the power 2.6 is 398. So that's the amplitude of this earthquake. Two decimal places or nearest hundreds. Remember going from a log into a exponential, right? This is the idea. Log b, again, it's gonna be like this. This is the bread and butter. So here we're in log form. How do you go into an exponential form? You're gonna use the formula that's on the left side to go from a log into an exponential.
X to the power of minus 2 equals 0.04.
That's right. How do you solve this for x?
You do negative square root.
This is what you do. Don't know what negative square root would mean in this context. When the exponent is negative, right? You want to
Mm-hmm.
throw it in the denominator, make it positive. And next, you want to swap positions because you're trying to solve for x. X is in the denominator. You want to move x over here. You want to move this over here. 1 over 0.04 is 25 equals x squared. What's x?
5.
5. Can it be negative 5?
Yes.
So it turns out it cannot be, not in this case. Yeah, technically it is plus minus 5. But for logs, you see both of these numbers here, this and this?
Mm-hmm.
They both cannot be negative. It has to be strictly positive. Because this is what it looks like. The graph of log looks like this, right? The x value will never be negative, okay?
Mm-hmm.
Because it cannot, there's a wall here, there's the vertical asymptote. Remember how we canceled out the 3 equals x equals 3 like this? We just straight up canceled out the 3's. This is the
Mm-hmm.
same kind of idea, but now it's flipped. Now we're looking at the inverse, we're looking at the logs. Can we cancel out those 7's, log 7's and log 7's?
Yes.
Yeah. So you get 3x equals 21 and x is 7. And that's it. Easy peasy. These next ones, you have to use the log rules. Right now, you can't cancel any of the logs. But if you're able to combine them into one log, then you're able to cancel them out. These are the two rules. Log a times b is log a plus log b. And log a over b is log a minus log b. So the goal is to combine them. The goal is to go from this side to this side, to combine them into one big log, so we can kind of cancel out the logs on the left and the right. Look at part A. How do we combine them? It's one of the two formulas up there.
You divide them.
You divide them. So what does it become?
Log 2 30x over log 2 5.
So it'll be log base 2 of 30x divided by 5, okay, like that. And 30x over 5 is 6x. Then you have log base 2 of 12 on the other side. Now can you cancel out the log 2's?
Mm-hmm.
Yeah. So this and this is gone. So 6x is 12, x is 2, you're done. Two-step answer. 2 steps. Nothing fancy going on here. What about B? What do we do for B?
You add them.
So what does it become?
Or you multiply them.
If you multiply them, what does it become? You multiply x and x squared. What's x times x squared?
X cubed.
X cubed. So log of x cubed is 12. So right now you're in log. You need to turn this into an exponential because you can't cancel out any logs at this point. Right now you're in logs, right?
Mm-hmm.
This is the idea here. So if you use that, we're on this form. We need to be in this form. What does it become for this guy? Remember, there's an invisible base there.
10 to the power of 12 equals x cubed.
Yes. Now you cube root both sides. This is the index. Remember, it goes in the denominator when you bring it inside, like that.
Mm-hmm.
So x is going to become 10 power 4, which is 1 with 4 zeros. So that's 10,000. And that's it. Same idea for this next one. There's multiple logs. Step 1 is to combine them. Step 2 is once you've combined them, turn it into an exponential. So here, if we want to combine them, what does it become? I'll give you a hint. It's the first log rule. Log A plus log B. This is the form that we're in right now. We can
Then you
combine.
multiply.
Then you multiply. So it becomes log A times B. So here we're going to do log of x plus 3 times x minus 3. Like that.
Mm-hmm.
Let's open this bracket up. What do you get when you open that bracket? You're going to get 4 terms.
X squared minus 3x
Yeah, what are the other two?
plus 3x minus 9.
Equals to 4. So this, we could have also used the difference of squares there. It's just gonna, this and this cancels out. So this becomes log of x squared minus 9 equals 4. So now there's only one log on one side. There's no canceling logs out. You have to turn this into an exponential using that invisible base. So what does it become?
10 to the power of 4 equals x squared minus 9.
Yeah. So x squared becomes 10 to the power of 4 plus 9, right? Is this a quadratic trinomial? Do we need to man this?
No.
No, this is not a man question. This is straight up just you add this up. What's that? 10,009. And then you square root it, and that's going to be your x value. Cool?
Mm-hmm.
Okay, there was a base 2 there. Okay, whatever. There was a base 2 here. So what the difference that would make is there was a base 2. The only difference it's going to make is that in terms of, instead of being 10 to the power of 4, it'll be 2 to the power of 4, which is 16. So you have 16 plus 9 equals x squared. So that's the square root of 25. It'll be 5. And that's the answer. It's technically plus minus 5. But if you use minus 5 as x in here, you'll get a log of a negative number, which cannot happen, okay?
Mm-hmm.
So that's why it's strictly positive 5. Let's try doing this one. Now here, again, if you look at it, there's logs on both sides. Combine the logs on one side and you can cancel out the logs, so you don't have to take it into an exponential. That's the idea for this one. And we can combine the logs on the left. There's a plus sign. How do you combine them?
You multiply.
You multiply them, right? So it's going to become log base of a it'll be x squared minus x plus 2x minus 2 equals log base a of 8 minus 2x. So this is x squared plus x minus 2 equals 8 minus 2x. Can we cancel out these two logs?
Yes.
Yes. So that's what we're left with. Let's move everything to the same side. This becomes x squared plus 3x minus 2 minus 8. So that's minus 10 equals 0. We're looking for two numbers. That multiplies to negative 10 and adds to positive 3. What are the two numbers?
Five and negative 2.
5 and negative 2 does it. So you have x plus 5, x minus 2 equals 0, which means x is negative 5 and x is 2. Can x be negative 5? Look at the first question up top. The question itself. Can x be negative 5?
No.
X cannot be negative 5, and here's why. Because if x was negative 5 here, you would get log base a of negative 3, right?
Mm-hmm.
This is not possible. You cannot have negative a in there because whatever the base is, it'll never be negative, okay?
Mm-hmm.
So that is simply not possible. So x cannot be 5, but x can be 2 because if you plug x as 2 in all the three brackets in here, you get a positive 4, you get a positive 1, and you get a positive 4. So x equals 2 is the only valid answer for this question. Okay, whatever, I want to do that. Let's try doing this one. So now this is a proof question. They've given us this initial condition, and we need to play around with it such that we end up over here. In the final bit over here, right? Do you see any logs?
No.
No. So the goal, so that's a big hint. You need to cancel out, you need to find a way to cancel out the logs from our initial condition. To cancel out the logs, you need log of something over here, and you need log of something over here. As long as it's a 1-to-1, you can cancel out the two logs. Here on the left side, we already have a log, right? So we don't really need to do anything with that. But we need to work on the right side. We need to work on this side. So we have two logs. We need to combine it into one log so we can cancel out with the log on the other side, and that'll probably give us the answer. So it's a little bit tricky, but let's try it. So on the left, we probably shouldn't do anything because we can cancel out this log as long as we can write logs on the right side. Use the log rules. How can we combine this into one big log? What will be the first step?
You multiply.
You multiply, so you get 1 over 2, and it becomes log of xy. And you also need to get rid of that 1 over 2. How do you get rid of that 1 over 2? You need to use this rule. If you have a times log of b, right? You can put this up top. So this becomes log of b to the power of 8. Remember that? We've been reversing it, but the other way also works. What that means is basically this 1 over 2 that's in the front, you can throw it in the exponent up here. And after that, you'll get the answer. Log of xy, right? To the power of 1 over 2, like that. Now, can you cross out the logs?
Yes.
Yes. So that's going to give us x plus y over 5 is equals to xy 1 over 2. Okay, we're on the right path. I don't see anything square rooted in the final answer, so we need to get rid of that 1 over 2 exponent. What do we do? You square both sides, okay? Because we don't see any square roots in the final answer. 1 over 2 to the power means square root, right? So we need to get rid of that 1 over 2 power. And the only way to get rid of that 1 over 2 power is to square root both sides. What do you get on the right side if you square root both sides? We have xy to the power of 1 over 2. We're squaring this. What do we get?
XY.
Xy. What about on the left side? So there's a squared here, right? If you have a over b squared, this becomes a squared over b squared. So in the denominator there, we will get a 25. What about the numerator? What's
X squared
x?
plus Y squared.
Look at this. This is a very common mistake, right? This is going to be 5 squared, which is 25. But if you open it like that, you're only going to get 9 plus 4. You're going to get a 13. 25 is not equals to 13, so you're missing something else. It is x squared plus y squared, but there's a third term attached to it. Here, let me show you. X plus y squared means x plus y times x plus y. When you open this, you get x times x, x squared, x times y, xy, y times x, yx, and y times y, y squared. These two are like terms. You'll get x squared plus 2xy plus y squared. So this is the missing component. In this example, if you do 2 times x, 2 times 3 times 2, that's a 12, and then it adds up to 25. So this is the missing component. It's going to be plus 2xy. We're almost there. I think it's just one more step. So in the final answer there, I don't see anything as a fraction, right? There's no denominators. So let's get rid of this 25. What do we do on both sides? To get rid of that 25, you multiply. So you get 2xy plus x squared plus y squared equals 25xy. Now what do? We only want x squared plus y squared on the left.
You subtract 2xy.
Right, you're gonna subtract 2xy. So it becomes x plus y squared is equals to 23xy, and there you go. We proved it. So the rules that we use here is the two log rules of log a plus log b is log ab. And then we cancel out the logs on both sides. and then we squared both sides. That's all we did. The big moves there. We also use this rule. A times log b is log b to the power of a, the power rule of log, rule number 3. Can we combine these two logs? Can we write that as one log? Or what would you do? The goal is to solve for x. So there is a log rule that exists. It's this one, log a over b, right? Like that. That is log a minus log b, okay?
Mm-hmm.
Which means you can't use that here because we don't have it in this form, nor do we have it in this form. So the log rules are not going to help us. What is going to help us though is our change of base rule, which says this. If you have log a divided by log b, this is the only formula that exists for this one, it becomes log base b of a. The thing in the denominator becomes the base up here, okay? So look at this. This is going to become log of base 5 minus x, and then you're going to have 35 minus x cubed up there, like that. Cool?
Mm-hmm.
Let's turn this into an exponential. What does it become? And this is the formula for it to become exponential. If you have something in this form, it becomes this.
5 minus x to the power of 3.
Yeah. Is equals to 35 minus x cubed. All right, so now this is going to be a little bit annoying. We need to open 5 minus x cubed. It is not going to be this, okay? This is a very, very common mistake.
Mm-hmm.
It's not going to be this. Both of these terms will be there, but there will be more terms. This one we have to old school it. There's another way of doing it with Pascal's triangle, but let's not get into that right now. 5 minus x cubed is just 5 minus x multiplied it by 3 times. So here this one is going to become 25 minus 10x plus x squared for the first two. And then it's going to become, I'm just opening this up, saving some time, minus 50x. Maybe I'll do this with minus 25x minus 50x plus 10x squared plus 5x squared minus x cubed. So this entire thing becomes, what is this, 125 minus 75x plus 15x squared minus x cubed is equals to 35 minus x cubed. Now this is a pure algebra problem from here on out. Our degree is 3. Can we cancel this term and this term?
Yes.
Yes. So by adding x cubed on both sides, they'll both be gone. Now we're just left with a simple quadratic. We've done this many times. To solve a quadratic, move everything to the same side. It's going to become 15x squared minus 75x plus 90 equals 0. If you can pull something out, always pull something out. Here we can pull out a 15. Becomes minus 5x plus 6 equals 0. Divide both sides by 15. 15 is gone. Two numbers that multiply to 6 and add up to negative 5 is negative 2 and negative 3. So therefore, your answer is 2 and it's 3, okay?
Mm-hmm.
Are they both valid? 5 minus 2 is good. 35 minus 8 is good. So 2 is valid. 5 minus 3 is good. 35. What's 3 cubed?
27.
So 35 minus, so both of them are valid in this case because they will both give us positive numbers when we plug it back in there. So this question, the most important step is the very first step. You have to rewrite those two logs as one log and turn it into an exponential. From here, it's just opening brackets and solving the quadratic.
Mm-hmm.
All right, let's call it a day there.
Okay, thank you.
See ya.